Hi, this is Subhodeep once again, and in this video, I'm going to teach about Lambda functions, some of the built-in functions of Python, which are map, filter, any, and all, and one another interesting function which is called reduce. So, before getting our hands dirty, let's give you a brief overview of what these mean. So, first of all, what are lambda expressions or lambda functions? So, lambda functions are basically, functions that return true, false, and all, and many things. Okay, so we can pass arguments like normal functions, but there is one distinction. Lambda functions do not have a name. That means we cannot call them. We can just create them, we can just use them, and that's it, finished. We cannot directly call them. Now, why is this an advantage? There are times where you do not want to actually make a function, because you see we are not really going to use it many more times in the code. Maybe we are just using it for only one time, right? So why would you make a function? That is the first thing. And you might say that I want to compare this, that, blah blah, and this is the reason before passing to some function I want to compare, I want to do this, do that using functions. That's good, but are you going to do it multiple times? Nope, you are not going to do. You are going to do it only one times only. So this is the reason we use lambda functions. We create a function, we use it, and boom, we do not use it anymore, right? Now, lambda functions cannot completely replace functions, because you cannot give so many of the things inside lambda functions. They're very, very, very small functions, and they're actually used to reduce the number of lines in the code. So let's say you want to compare that your given number is more than 10 or not. Let's say you give a number 5. So is it more than 10? Nope, it is not. So you just want to compare things, right? So then that's when you use lambda functions. Or let's say you want to give the square or cube or quadratic, whatever. Let's say you want to solve an algebraic expression. Now, what are algebraic expressions? If you have studied mathematics, there are things like a square plus b square plus 2ab and all those stuffs, right? So you want to compute the value of that thing using a particular value of x or y or a or b, whatever. So lambda functions are a great way of solving algebraic expressions. It is really, really a great way. Or for the sake of simplicity, let's say you want to compute what is x raised to the power 32, right? So let's say for in this case x is, let's say, 5. So it is 5 raised to the power of 32, right? And you want to compute this, and that's when you use lambda functions. In lambda functions, you do small things like comparisons, solving of algebraic expressions, and all those stuffs. And we will look into that in just few minutes. So that is lambda expressions. So what are the objectives of lambda functions? First one is to reduce the number of codes you're writing. For function, you have to write at least 2 or at least 3 lines of code, right? But in lambda expressions or lambda functions, you just write 1 line and it's done. Now, that is the beauty of lambda expressions or lambda functions. What is another objective? The next objective is to do small things like comparisons or solving of algebraic expressions and stuff like that, to return true, false, and whatnot, right? So you want to you want to compute something, you want to check something. That's when you use lambda functions. So that is one of the objectives of lambda functions. Now I'm going to show you in a minute. That is one of the things. Now again, you can I just told you that you can pass many parameters, or I'm sorry, many arguments, just like a normal function, right? So we will also see that we will work with arguments, we'll work with parameters also, right? Now our next topic is the functions, the inbuilt functions of any, all, filter, map, and reduce, right? So let's go one by one. let's say there is a job interview, and let's say there are there are 1,000 candidates. I mean, those who applied for the job, right? So there are 1,000 people who applied for the job. Now, the thing is, you won't take 1,000 people, right? You will, of course, select some of them, because you do not have place to keep 1,000 people, right? And moreover, you want the quality, right? Let's say you are an employer. Let's say you have a company and you want to hire somebody. You obviously want to take someone who is capable enough or is expert of his or her field, right? Now you will have to choose some of them among the 1,000 candidates. Now, or in other words, in English, we can say we will filter them out. We will filter the 1,000 candidates out. Now, that is filter function in Python. We are filtered according to a condition. Now, let's say your condition is that every employee must have a PhD. This is your condition, that every employee must have a PhD. That means you will check every candidate's form. Okay, does he have a PhD? Well, okay, I keep him. Does she have a PhD? Yep, okay, I keep him. I'm sorry, I keep her. Well, does she have a PhD? No, she doesn't. Well, throw it out. Does he have a PhD? No, throw it out. Does he have a PhD? Yep, keep it. So just like that, we are selecting among the various options. Now that is filter. We are selecting some of them among all the different options. That is filter function. That's the work of filter function. And now I just told you that we are checking against some condition. We are checking that I should select him or her not, right? So how can we check it? We are using functions. We will pass each of the thing or element into some of the functions, and the function will check it. In this case, let's say you have a person. Let's say you are the employer. But obviously you do not have the time to check every applicant's application form and to verify if he or she has a PhD or not, right? So obviously you will have a person that you will hire who will check all these. Like, let's say you hired someone who will check this for you, and that person is the function. Okay, so this is you, this is me, and I am hiring somebody else. Now this is the function guy, and then I am taking the application and giving him, and then he will check me and return to me if I should keep him or not, right? So let's say I give the application form to that guy, and that guy say no, he does not have a PhD form. He won't say that do not keep him. Okay, it's my job to decide if I should keep him or her, but he will only tell me that this candidate does not have PhD. Now based upon that, I will decide that no, I won't keep this candidate. Now this is how filter function works. So basically you pass two things inside filter functions. Two things, right? So inside filter function, the first thing you provide is that person, or in terms of computer, that function, which will check the thing for you if that condition matches for you or not, right? And that function will either give you true or false. So if you say, well, is this number bigger than 10? So the answer will either be true or false, right? It cannot be anything else. Is 5 bigger than 10? You will say false, right? So there will be two options, either true or false. Now let's say that person says that this person has a PhD. Now I'll see, well, that means it returns true. I check, does that person have a PhD? And it says me true. I see, well, it is true. Okay, keep him. Does that person have a PhD? No. That person says no. I take it. No. That means false. I throw it away. I do not keep it. Right? Similarly, if I give a number, let's say 6, or let's say I give at least 5 numbers. So I say 1, 2, 3, 4, 5. And now I check. Is any of them bigger than 5? I'm sorry. Is any of them bigger than 3? So let's say I provide 5 numbers, 1, 2, 3, 4, 5, and I check if any of the number is greater than 3, I will keep it. else I will throw it. So I basically take a number, throw it to that function, and that function gives me no, it is not bigger than 3, right? And what should I do? I just throw it. I do not keep it, right? Now that function's job is to tell me whether it is true or false. That's the only job that function is going to perform. That function will either give me true or false. If it is true, I will keep it. If it is false, I won't keep it. That's the simple logic behind filter function, right? If a thing matches a certain criteria, I keep it. I keep it. If a thing does not matches that particular criteria, I discard it. I remove it. I throw it. Whatever you can say. I throw it in the dustbin. I kick it out or whatever. So that is a function of filter. And the next function is what should I say? Reduce. Well, I will go to that later on. So the next function is map. Map. So map is also a built-in function. Now, what is the purpose of map? So let's say there are again. Let's take that previous example because that is fun. So let's say again you have a you are the employer, and there are 1,000 candidates who have signed up for the job. Now in their application they have mentioned Donald Trump. I'm sorry, Joe Biden. Barack Obama and all those. Okay, so they have given their full name. They have given the full name of their. But you want to keep the first name only. You do not need the last name. You only need the first name. For everything, for every name, for every full name, you cut it in half and you take the first part and you remove the second part. What will you do? You will use map function. You will say map function that, hey map, do one thing, just cut it out and then keep it, right? So that's the job of map. So map will, and how can map achieve this thing? Again, the use of functions. Map will not itself cut it. Map will give the element to another function. Now that function's job is to cut it, take it and give it back. Okay, it's not map's function. Okay, it's not map's job. Map's job is to give every element, is to take every element and give it to the function which will be responsible for the job. So map is the supervisor who oversees everything. Okay, he is the class monitor or the teacher, whatever you can say, or the big boss of the company, right? So here map is the boss, that function is his employee, and that function's job is to do all the stuffs. Okay, now let's give another function. Let's say I give you 5 numbers. Let's say 1 2 3 4 5. I give you 5 numbers and your job is to compute the square of every number. That means you have to compute 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and 5 square is 25. Now, do you notice some similarity? Yep. We are doing the same thing again and again and again. We are doing the same thing. We are computing the same thing again and again and again. Now you must say, if we are doing the same thing again and again and again, why don't we use for loop, right? Let's say I have a for loop. Let's say I have a for loop, and using that for loop, I iterate through every element of the list, or for every number, I compute or I just calculate the square of the number and put it back into some another list, right? You might say this, but that will make the code longer basically. So why not do it in just a line? Why not do it just a line? Now you will say, well Subhodeep, let's say we can do it in one line, but you just told that we need a function to do this job. Now we need another 3 lines to write this function. Now here comes lambda function. Of course you can use the traditional functions, like you can say def is big or is more than 5, and then you can write the function, then you can return things. That is one way, but we are not going to do it because it is not efficient. You may of course do it. It is technically possible, and people do it, and that is okay. But you guys don't, because that is not a good practice. If you are using map, filter, any, all these stuffs, don't use functions. Don't use traditional functions unless and until you really goddamnly need to. Okay. Now let's say you want to check if a number is Armstrong number or not. Now that time you may need that big function. You have to write it, and then you have to check it, right? Now that point it is okay. But let's say you just want to do simple calculations. Let's say you want to compute the square of a number, cube of a number. Why write a 3-line or 4-line function for that? Or at least 2-line of function for that? Why not include it in the same line, okay? So we do not need to write separately the function. Although we can, of course we can, but we don't need to write. We will use lambda functions because lambda function will do the job in just a line. That's the specialty of lambda functions. That's why lambda functions were created, right? And of course you are not going to need it more than once, so what's the point of making a function? Now let's say if there is an Armstrong number function and you need to use it more than one times, then maybe a function is okay. The traditional function is okay. But when you do not need it, you just need it to convert all the numbers into their squares. Why write it? Waste of time, waste of line, all the waste. So better do not write it, use lambda functions. So using map functions, we can do the same thing for every element in a list or in a tuple, okay? Or any iterable. Anything that is iterable, will work. So let's say you give a list of numbers and you just want to calculate the square of a number or cube of a number or whatever. You may want to solve an algebraic expression with that. For the value, x for the value of 1, x for the value of 2, and all those algebraic stuffs. You want to do that, you can just use a lambda expression, right? And we will, it may sound confusing right now. Do not worry, I am here for you, and I will show everything through Python, okay? Because that's what we do. We are programmers, we write programs. Now, that is the job of map. Now, let's take another example of map. Now, let's say you want to do, let's say you have an expression, let's say you have a plus b, okay? You have a plus b. So what can you do? You want to compute a plus b for everything, right? Or okay, a plus b is a little more complex. Let's say you want to compute if the number is even or odd. This is a great example, right? Or yeah, okay. So if the number is even or odd, so you have a list of number 1, 2, 3, 4, 5, 6, 7, whatever, 10 up to 10, whatever. Now you want to check if every number is true or false. If it is true, if it is even, it is true. If it is false, if it is odd, it is false. So what can you do? Write map. Map is here to help you. You do not need to write functions separately. Okay. So you will use a lambda function and you will give it to the map. That means the map will, the main purpose of map is the map will take every element from the list you have given and it will give it to that function, which will check if the number is even or odd. If it is even, it gives us true. If it is odd, it gives it false. And the new list will be true and false. Although that doesn't make any sense. It will make sense once you start to code it out. Again, in brief, we can say that if you need to do something for every element of the list, try to use map. Again, I am repeating, if you need to do something for every element of a list or tuple or any goddamn iterable, okay, you just try to use map with lambda, okay, or at least map, and that will make your lives easier, trust me. So what's the next function? What's the next function we have? The next function in the list is what should I say? Reduce. Yep, reduce. Okay. Let's say what's the function of reduce? All reduce does is takes so many different values and gives you a single value. It gives you a single value. Remember that. So let's say again, here reduce is the boss. Remember that reduce is the boss, and again the job will be done or performed by someone else, and that someone else is the function. Now, let's say you have a function. Again, I'm talking about lambda functions. Of course you can write traditional functions, but I would not suggest that. Okay, so let's say you have a function, and that function, it does what it does is, it takes two numbers, adds it. So it takes two numbers from the list. Let's say you have 1, 2 and 3. So it will take 1 and 2, add it, and it will give you 3, right? And then again, it continues to do that. So you have a function like that, and you want to, just apply it. You want to, let's say you want to calculate the sum of an array. So obviously you will say, well, Shubhadeep, there is a function called sum. Why can't we use it? Of course you can use it, but some function will give you additions, right? But let's say you need to divide things, or let's say you need to multiply things. Now what? Now you have to use that reduce function only, right? So let's say you need to, for the sake of simplicity, I am saying this. Let's say you need to add all the elements in an array. Normally you would do sum, name of the array or list, and boom, finished. But here what you will do is, you will say, let's say you have three numbers. You have passed a list which has three numbers, 1, 2 and 3. Now you tell reduce to reduce three of them into one. That's the only job of reduce. The name justifies it, right? It reduces everything into one single result. So now reduce takes every number and puts it into lambda expression or function, whatever you call it. So let's say you have a function which takes a and b and adds them. So the reduce function takes 1 and 2 and then puts it into that function. Now that function will calculate it. So 1 plus 2 is 3. It will give us 3. Now what is the next element? Because we have taken a and b, right? So there are three elements. We have taken 2. The remaining one is, there is only one element. Now what will happen? That previous 3, 1 plus 2, 3 is the new x. And what's the y? What's the y? So I have taken 1, cut it. 2, cancel it. Now 3 is remaining. Add 3 to 3, you get 6. That is what reduce function does. Now it will give you a total of 6. So that's how reduce function works. Reduce function takes lot many things and then does some calculation with the help of that helper function or that other function, right? It may be lambda function, it may be some other function. Just does the work and then gives you only a single value. Only a single value, remember that. Now, so these three are very important. Now let's come to our next function. So our next function is all. For the sake of simplicity, I am taking a simple example. Let's say you have a list of numbers. Okay. So the numbers are -1, -2, 5, 6, 7, -3, -4, 8, 9, 10, and then -11, -12, 13, 14, 15, and stuff like that. Right? Now, let's say your job is to check if all the elements in the given list are positive numbers or not. If all the elements of the given list are positive number or not, that time you will use all. Now what you will do is, you will say, check if every element of the given list is more than, is more than 0 or not. Because if a number is more than 0, it is positive number. If a more is less than 0, it is negative number. Or if a number is equal to 0, then it is neither positive nor negative, right? So only the numbers that are more than 0 are allowed, that are positive numbers, right? So you have to check that thing. Now you may say, Shubhodeep, do I have to use lambda functions once again, or do I have to use functions once again? No, you don't need to. Why you don't need to? Because all, the function all, it won't accept, more than one argument. You can pass only one argument. So in the list itself, you will write You will use list comprehensions. I'll show you. But just remember this thing. If all the elements are true in a list, then it will give you true. If even one of the element is false, let's say you have 10 elements, and even if one element does not satisfy this condition, the whole thing will be false. So you are checking if all the elements are positive or not. So there are -1, -2, all those stuff. It will give you false because not all the elements are match that criteria. Not all the elements are positive. There are negative things. There are zeros and all, right? So it will give you false. Now let's come to any. Let's come to any. As the name says, if any one of them justifies the condition, satisfies the criteria, then it is a true. It is just like and or. It is just like and or. Okay. Remember in the very first lectures I have shown you, when you use or, if any one of them is true, it will give you true. It really doesn't matter if the other one is false. If any one of them is true, it will give you true. If and only if all the things are false, that time it will give you false, else it will give you true every single time. If two things are true, it will give you true. If one thing is true, it will give you true. Only if and only if all the things in the comparison are false, it will give you false. This is or. But when it comes to and needs all the things to be true. So let's say you have two things that you are comparing using and. So you are saying this condition and this condition. So both the condition must satisfy so that and gives us true. I'm sorry. It's common cold, It's near about December, and in India, cold is approaching very fast. Anyways, so yeah, just think any as or, all as and. That's the only thing. So again, I am repeating, when you are using and function, you are checking if all the elements in that list or in that tuple matches that criteria or not. When you are using any, you are checking if any one of them matches the criteria or not, right? So in case of all, if all the elements matches the criteria or the condition, it will give you true. Even if one of them fails the condition, it will give you false. And in case of any, if even one of them is true, it will give you true. Only if all the things are false, it will give you false. That is the difference. Now, this is a video part. This was the basic overview. So now the overview is complete, and now let's get our hands real dirty. So now let's start with the first topic, which is lambda functions. Now let's say you have a function, and I don't need to explain how to write functions because I have already explained it in earlier videos. So let's write a function. Let's say square. So this is a number, right? So we say square, and it takes one argument, and it returns num to the power of 2, right? So this is the square of number, right? Okay. So now if I say something like this, sq square, and I say 5, it gives us 25. Square, it gives us, if I say 10, it gives us 100. So it is doing its job, right? Now you are writing it two different lines of code. The only advantage is that you can call it anywhere in the function. I'm sorry, in the code, right? Now, what does a lambda function look like? Let's have a look. So this is called lambda function. Lambda, you say lambda. See, it immediately turns into orange color, right? So you say lambda, then you give a space, then give all the parameters. Okay, so let's say num, and this num is same as this num. Okay, And just like we had a colon here, we have a colon here also. And simply give a space and then say num squared. And boom, we have a function ready, but we cannot use it. You want to see this? Boom. So it actually does nothing, but it just gives this message. And basically this is not usable because it does not have any name, right? In case of this one, we had a name called square, so we could call this using square and then give something 5 or 10 or whatever we like. But in case of this, there is no name, so in order to use this we need to store this in a variable. Although we don't do this, this is just for demonstration, so we have to store this in a variable. So we copy this and we paste this here. Now we can see how to work with. So just like we call function using the name of the function, in case of this, use the name of the variable where it has been stored. So what is the name of the variable where the lambda function is stored? It is x. So say x and pass 5. It gives us 25. Say 10, it gives us 100. Say let's say 2, it gives us 4. So it works perfectly fine. All you have to do, you have to store it inside a variable. We don't do this in reality actually, or if you are thinking you want to make it short, you want to keep it short, then only you are going to keep it inside a variable. But this is a bad practice. Don't use this unless and until you really need it. Okay. So we can use lambda functions like this. Also, we can use lambda functions inside a normal functions. How can we do that? Let's see. So this is one of the way of calling lambda functions. Write a lambda function, store it inside a variable, and then call it. Now let's write another lambda function. So let's say we have how to you know how to write lambda function. Let's say x equals to, and you say lambda, and you say let's say okay, let's give multiple arguments. So let's say num1, num2, and num3, and then give a colon. Okay. And say okay, these are the parameters you have, and you will need to pass 3 arguments, right? Arguments are what you pass and parameters what it needs, right? So basically if I have put, if I had put here num1, num2, and num3, this is basically same as this thing, and again give a colon. Then let's say num1 plus num2 plus num3. Okay, so this is our lambda function. And now if I say x, see, it tells us to pass 3 arguments. So let's say 1, 2, and 3. So 1 plus 2 plus 3, it gives us 6. So it works perfectly fine. Now it can be used in some other places also, right? Like in a function, in some other traditional functions. Let's say def. Let's make a function again. So let's say demo, and we have to pass num, and inside the return statement we say return, and we say lambda. Now inside the return statement we are defining another function, but it is not a normal function, it is a lambda function. Now we say lambda, and we say x such that, or colon, x plus num, and let's see what happens. Now if I say like like this, let's say demo, and you pass something, let's say 4, this won't work. You can see this won't work. Function demo.locals.lambda. So it actually says that there is a lambda function and it cannot directly be called, or it cannot work simply. So how can we make this work? Again, you have to store this thing into something, some variable. So you have to say x equals to demo, and then you put something, let's say 2. Now you call x with some other thing, let's say 4. See what happens. 4 plus 2 gives you 6, 5, 6, right? 4 plus 2 gives you 6. So if you are doing this thing, if you are using lambda inside some other function, first you have to call the function with some argument, but you cannot directly use it, so you have to put it inside some variable. And just like you call lambda functions using that variable, just call that variable and pass the value of x. So do not get confused, this 2 is this num, okay, and this 4 is this x. So it needs two value, right? It cannot work with a single value, okay, it cannot work with a single value. Although let's see what happens if I do not pass a lambda lambda parameter. Let's see what happens. So again we have demo and we have num once again, and then we put a colon, then I say return. Now I say lambda and I do not pass anything. I can do this, okay, I may choose to not pass anything, okay. So I don't pass anything and I say num num plus num, okay. So I want to add num with num, okay. Now let's see what happens. You may be thinking that this will work, right? Let's see what happens if I call it. Boom, it doesn't work. Now you may argue that, well, I haven't passed anything here, so we have already passed num, so it can completely do num plus num, so why cannot it do it, right? Why can't it do it? Because of this lambda. Whenever you use a lambda inside some other function, you have to call this in this way. You have to store it in some variable x equal to demo, and you have to put something inside it. This is the value of num. You can see this is num, okay, and then you call that variable using some other value, some other value. And did you notice this thing? Okay, not this one. 5 or 4, yeah, 4 5, done. Now if I call this, oh, so what's happening? Oh, I'm sorry. Damn, I it says type error. Lambda takes 0 position arguments, but 1 was given. So it basically saying that you don't have to pass anything, but you have passed something, okay. So don't give this thing, just call it, like, so you say x and it just adds 4 plus 4. So I guess you are starting to see what's happening. Basically you are not passing anything, this is empty, okay. Here this was x, but here it is empty, so you do not need to pass anything. If you pass something, it will say that it takes 0 number of items, but you have passed 1, and that is an error, okay. So mind that. Now again, let's call it again. Let's have some practice. So again, let's store it somewhere. Let's say y, and this won't work. Boom, y is not defined. So first we have to define y. You say like this. So y equals to demo, and you put something, let's say 5, and then you call y like you call a function, and do not pass anything. So it gives you 10 because you are not passing anything. Okay, so that's how you work with lambda function, and the concept is pretty easy, right? Now that's how, since you know how to work with lambda functions, now let's see how to solve algebraic expressions using lambda. So if you had studied mathematics in your school, at least in class 6 or 5, in grade 4 or 5, then you may know that what are algebra, okay. So let's say we have something like this: a plus a square plus b square plus 2ab. So you need to solve this. So what are the variables here? B and a, right? See, we have only two things, a and b. So let's say we need to solve this. And in this case we need to pass two things, that is a and b, because there are only two variables, a and b. Rest are just numbers. So we need to pass two things. So I'll say lambda, and I say I hit a colon here, and since I need to pass two things, I will say a comma b, right? So that's what we need. And now we store it in a variable. That's x equals to. So in algebra we write x equals to just ignore this thing, ignore this part one. But in mathematics, if you have studied mathematics in your school, you know that you say x equals to, then you say something like this thing: a square plus b square plus 2ab, right? Something like this, right? What happened? Oh, I'm sorry, I'm sorry. You cannot write 2ab together. Okay, you have to put multiplication. So let's copy this. And again, v is 2 into, okay, perfect. Yep. So now we have this whole expression, this big expression. So a square plus b square plus 2 into a into b. So this is a algebraic expression. If you have studied mathematics, you know this. So x equals to a plus b whole square, and a plus b whole square gets converted into this thing. You don't need to know it. I'm just saying. So if I say x, and then I need to put values of a and b, right? So the interpreter is showing us that we need to pass two things: the value of a and value of b. Let's say the value of a is 2 and the value of b is 4. Okay, let's see what happens. Okay, 36. Now let's see how we get 36. So a is 2. We have passed it inside here and it goes in here. So 2 to the 2 raised to the power 2 gives us 4, and this is 4, and 4 raised to the power 2 gives us 16. So 16 plus 4 gives us 20, and then we have 2 into a into b. That means we have 2 multiplied by 2, that is 4, multiplied by 4, that is again 16. So 16 plus 16, 32, and plus you get 4. So 32 plus 4 gives us 36. Okay, so that's how it's solving it, right? So that's how you solve the algebraic expression. Now let's write something else. Let's write another algebraic expression. Let's paste it and let's remove it. Let's say you have this. So you say if you have solved quadratic equations in your school, then you may do this, and you don't really need to, because I'm just demonstrating it. Okay, so I will say let's say 5, or let's say 4, let's say 5 to the power of, okay, not this one, let's say 5 multiplied by a, which is raised to the power of 3. Put this inside brackets. So I am basically saying a cube, so that's why I am putting this inside brackets. And in mathematics we would have written this as 5a cube, and then we say plus, and then I say 2 multiplied by b raised to the power of 2 plus, simply just give c. Okay, so if you have done quadratic equations, you have solved equations in your school, then you might know this. So in mathematics we would have written 5a cube plus 2b square plus c. Okay, so this is a quadratic equation if you do not know. Anyways, so what do we need to pass? We need to pass a, b and c, right? X, a, b and c. The value of x is, let's say, 2. The value of b is, let's say, 3, and the value of c is, let's say, 4. And let's see what happens. So it is 62. Now if we start to calculate it, it would be very long, but still let's see what happens. So a raised to the power 3, that is 2 to the power of 3, that is 2 cube, is 2 to the 4, 4 to the 8, and it gives us 8. 8 to the 8 multiplied by 5 gives us 40, and now in here the value of b is 3. 3 square gives us 9. 9 multiplied by 2 gives us 18. Okay, so 18 plus 40 gives us 58. Okay, and then we have c, whose value is 4. So 58 plus 4 gives us 62. So that's how you solve algebraic expressions using lambda functions. So that was the basic of lambda expressions. Okay, now let's move on to our other core topics, which are the built-in functions. Now we will start with the filter function. Now the syntax of filter function is like this. You have to write this one. Let me go here. Yeah. Now you have to write filter. See, it turns to pink, and well, and inside this, the first thing you have to pass is the function name, and then anything that is iterable. Okay, so it can be a list, it can be a tuple, it can be a set. Okay, it can be any of these. It has to be iterable, and let me just give any, iterable. Yeah. So this is the list of elements that we will pass, and this is the guy who will do our actual job. It will check if our elements are true or false. Okay, so there will be a condition inside this, and it will check if every element inside this iterable or collection matches the given condition. If it matches the given condition, it returns us true, and if it returns true, then the task of filter is to keep that element inside it. Okay, now it will be more clear with this example. Let's say you have a function. Okay, and the function's name is positive. Okay, so this is the function is positive, and you pass something, some number, and you say if num more than 0, return true. Return, or you can put a else in here, but you don't really need an else, because if your number is more than 0, it will be returning true, and once it returns something, it won't come back, so you do not need to worry after this. So you can directly write return false. So this is basically, if your number is more than 0, it will return true. If it is not, it will return false. And we do not need else here, although you can put obviously, but we don't really need else here, because if and only if your number is more than 0, it will return true, and you are not saying anything else. If it is less than 0, if it is 0, okay, it will give false. You can obviously put elif. You really don't need to do that. Okay, this is okay. What happened, dude? What happened? Okay, I see. Perfect. So this is a function now. Let's check if our function works properly or not. Is positive. Okay, and we say 5. True. Okay, so that means our number is more than 0. That means it is positive. And then I say is positive, and I give 100. It gives us true. Let's say is positive, and now give negative 5. Let's see if this works. So it gives us false, because it is negative number. That means it is less than 0. Is positive, and you say minus 677. It gives us false. Again you say is positive, and you check if it is positive, and you say 0. It gives us false. So you can see that it works perfectly fine. Only if you give a positive number, it will give you true, else it will give false. Okay, now every single time it says true for a number, the filter function will keep it. How? Let's see that in action. Now let's write filter. We have it here. Now uh, the first argument is the function that will check if the element matches the criteria or not. So the name is positive, right? And what is the next thing? Next thing is the collection of items or lists or tuples or any iterables. So let's say we pass in a list which has 1, 2, minus 10, 0, minus 100, okay, minus 111, 56, 67. Okay, so let's see what it does. And it does really nothing, because just doing this won't really work. It will give you a filter object. Okay, you know, in other words, it won't print anything. So in order to make it do something, you have to say, you have to convert this into list. Inside list, you are converting this whole thing into a list. Boom, you get 1, 2, 56 and 67. Why? Because only these numbers are the ones which get a true value when it checks. So let's understand what's happening. So our filter function starts from here. Okay, well, this is our collection. This is the list of items we are passing, and our filter function starts from this number 1. So now it passes 1 inside this. So now num is 1. Now if num more than 0, that means it is checking if 1 is more than 0. Of course it is, so that means it returns true. Since it is returning true, we will keep 1. So see, we can see that we have 1 here. The next element is 2. Now the filter function is passing this 2 over here into this num. Now the value of num is 2. Now it is checking if num more than 0, that is, it is checking if 2 is more than 0. So again, this is true, it returns true. Now since is positive gives you true for this value, thus keep this one. So again we have this. Now the next element is minus 10. Now filter function, takes this one and passes it to here. Now it check if num more than 0. Now it is checking is minus 10 or negative 10 more than 0, and this condition is false. Now you don't execute this part, that means the next part is return false. So it is returning false. And since is positive is returning false, this function is returning false for this particular value, we do not take it, right? We do not take it. So as you can see, there is no negative 10 in here. In the new list, there is no negative 10. Now the next value is 0. Again, filter function passes this 0 to here. Now if we check, is 0 greater than 0? No, it is not. Thus this condition is false. Again we just skip this one and we return false. And again, since is positive is giving false for this value, we again won't keep this. So as you can see, we do not have 0 in the new list. Now then again it happens for minus 111. This condition is false, that means it returns false, and thus we don't keep this one, because for this element we get a false, and for 56 we get a true, for 67 we get a true. That's why we will only keep those elements for which this is positive function is giving us true. So this is the value where we get true, this is the value where we get true, this is the value we get true, this is the value where we get true. Thus we keep only these 4 items in here in the new list. So we again make a new list. Okay, and this does not happen automatically. Okay, we are getting this list because we have said this one. We are converting the whole thing into a list. Okay, remember that. This is the reason we are getting a list. Okay, now let me give you another. If I say I will use a tuple, and let's see what happens if I put a tuple in here. See, it gives us tuple. If I say if I put the same thing in here, let's say this time I say set, and I do this thing, boom. So again I get this thing, although in set order doesn't matter. I have told you this is the reason it is in unordered format. So yeah, you get the idea, right? So this is how it works, right? Now one warning. You may think that you are calling a function that is positive. Is positive is a function, right? Is positive is the function. But you might say that you will call function like this. Don't do this. Okay? Don't do this. Why don't do this? Because you don't want to call this function. Okay? You don't want to call this function. Remember this. You do not want this function to execute itself inside this. You are not executing inside this. You are passing every element to this one. So basically you are referring to this function. You are referring to this function. So if I refer to someone, let's say we have John and Bob here, and if I refer Bob to John, I won't call John, but instead I will say, hey Bob, go to John. So this is our John and this is our Bob. This list is our Bob, and I'm saying, hey Bob, go to John. So I am referring this thing over here to this thing, and we are not calling this thing. Remember that. Okay. Now that is how we use filter function using our traditional method. Okay. I'm sorry, traditional function. But we can do this in a single line. We do not need to write the whole function. We can completely avoid this one. How can we avoid this one? Let's see how we can avoid this one. So if I say something like this, let's say list, because I want it to be a list after it is after it is converted into a filter object. Now I say filter, and I say lambda. Now look at this very carefully. Now I say lambda x such that, or lambda x colon. So this is basically just a regular function without any name. Okay. Or for your just give it num. Why num? Because when we were using this is positive function, we were passing the argument as num, and just for the sake of simplicity I am giving this num. You can put it whatever you like. Okay. Now what you will say is num more than 0. Finished. We are done here. Okay. Now more than 0, and then you will say comma. Okay, just remove this thing. Just start from the beginning. Filter, and the first thing you give is lambda function instead of a regular function. Lambda x, and you say x more than 0, and you put the iterable thing. Let me copy this one, and you put it here, and let's see if this works or not. Okay, yeah, I need a list in here, and I'm gonna explain it. Just hold on. Let's pass it, and I say list. I'm gonna make it a list. Okay, boom. So we get the same result. We get the same result without writing any function. Why are we getting this? Now what is the first element in here? It is 1. So filter function takes this one and passes this to lambda function. Okay, now where is the lambda function? Here is the lambda function. So the value of x is currently 1, right? So now filter has passed 1 to this lambda function, and thus the value of x is 1. Now we are checking, is x more than 0? This is a comparison, right? This is a comparison, right? So if I say, for example, x equals to 5, and you just say x more than 0, it will give you true. But if you say x equals to, let's say minus 111, and you say x more than 0, it will give you false. So that's how it is working. So we are just comparing the thing. We're just comparing the three, and this comparison will either give you true or it will give you false, right? So for this element we get a true because x is more than 0, obviously. For this element again we get a true because the current value of x is 2 and x is more than 0, so again we get true. For negative 10 we get false because negative 10 is less than 0. and for 0 again we get false. Why? Because 0 is equal to 0 but it is not more than 0, remember that. So basically this is a function, this is just a one line function, and basically here you would have said def is positive num, and instead we are saying lambda x, or you can simply write it lambda num or whatever you like. Okay,